Okay, ladies and gentlemen, I'm going to show you as many ways as I can to solve the problems from the quiz that we took on Friday. Hopefully so that those of you who are confused can see how simple it actually is, as long as you're willing to use your creativity and think about the strategies that you have at your disposal. That is my kitty Marble, and she's going to meow while I do this. So, I made it easy. 5, 20, and 25 are all divisible by 5. So if you're going to complete the square to put this guy in vertex form, you start by dividing by 5, which gives x squared plus 4x plus 5. Now to complete the square, you want to take half the value of b, which is 4, and then square it. So half of 4 is 2, 2 squared is 4. So here's option number 1. You could take x squared plus 4x plus 4 plus 1. At which point, half of you guys scream and say, oh my God, I don't understand why you did that. Does it make any sense? You're right, it does not make any sense that 4 plus 1 is equal to 5. I disagree. We write 5 as 4 plus 1 because it makes it possible to complete the square. If you look at these three terms, you have got a perfect square. So you can rewrite those three terms in factored form. X plus half of b squared. And if you don't believe me that those things are the same, let's just take x plus 2 squared and write it out longhand. Foil it out, as it were. First, outer, inner, last. So x times x. Here's the first part. X times x. That's x squared. Outer. That's the two outer terms, x and 2. Inner. The two inner terms, 2 times x. And last, 2 times 2. Combine the like terms together, and you end up with x squared plus 4x plus 4, which should look very familiar because it is exactly the way I said. Those three terms, when written in factored form, are x plus 2 squared. So we write in factored form, x plus 2 squared plus 1, and that's it. Oh, wait, except for the 5 that we divided away at the beginning. At the beginning, we divided every single term by 5. So to undo the damage that we created, which was a movement of the vertex when we did that, we need to multiply every term by 5. So essentially what you're doing is taking every term in this expression and multiplying it by 5. The 5 distributes to the x plus 2, and the 5 distributes to the plus 1, leaving us with 5 times x plus 2 squared plus 5. There's your vertex form. Vertex is at -2, +5, and that's one of the points on your graph, the vertex. Now maybe you don't like that method, and you always want to have your equal sign in there. That's fine by me. You can still begin by dividing every term by 5, including the 0 on the right-hand side of the equation, to get x squared plus 4x plus 5 equals 0. Why equals 0? Because 0 divided by 5 is still 0. Now, maybe you don't like having that positive 5 right there, so you're going to subtract 5 from both sides so that it's easier for you to see what value you need to complete the square. What value should you add to both sides to complete the square? Half of b, which is 4, squared. So add 4 to both sides because 2 squared is 4 and 2 is half of b, giving x squared plus 4x plus 4 equals -5 plus 4. The three terms on the left, again, simplify to x plus 2 squared. -5 and +4 is -1. And then we can set it back equal to 0 by adding 1 to both sides for x plus 2 squared plus 1 equals 0. Undo the damage of dividing by 5 by multiplying everything by 5, and we are exactly where we're supposed to be. I multiplied every single term by 5. The x plus 2 squared got multiplied by 5. The +1 got multiplied by 5, and yes, even the 0 got multiplied by 5. How come it didn't change? Because 0 times 5 is, always has been, and always will be 0. These are things you know, yet somehow many of you have yet to put it together all in one place in the context of completing the square of quadratic equations. That's fine. You have time to get solid on this before the EOC. But it's going to take effort on your part. I had one student come to me and say that she spent 2 hours watching videos on Khan Academy to really get confident with this. That is the mark of a successful student. Somebody who knows she does not understand, so takes the time to figure it out. We live in the age of Google. Put in, how do you do vertex form? You'll get hundreds of results with examples and sample problems and videos if what we're doing in class isn't good enough for you. All of you are smart enough to figure this out, but it's going to take time and effort on your part. Let's look at yet another way we could have done this problem. Begin by dividing by 5, get x squared plus 4x plus 5 equals 0. And we know that the x term is always going to be right on the axis of symmetry. The opposite of b divided by 2a. The opposite of b, well, b is 4, so that's the opposite of 4 divided by 2 times a. After we divided by 5, a is now 1. So the axis of symmetry is located at x equal -2. Take -2 and plug it into your equation to get the proper y value of the vertex. -2 squared plus 4 times -2 plus 5 is equal to 4 minus 8 plus 5, which is equal to 4 minus 8 is -4 plus 5 is +1, which means our vertex form must be x plus 2 squared plus 1, but then we can go back and undo the damage of dividing by 5 by multiplying every term by 5. And we are right back at vertex form. If that seems a little magical to you, you can do the exact same thing without ever dividing by 5 from the beginning. Our vertex is always located at the opposite of b over 2a. So that means that x must be equal to the opposite of 20 divided by 2 times 5. And lo and behold, the value of x is still -2. Why? 2 times 5 is 10. -20 divided by 10 is -2. Now take that value and plug it into the equation. 5 times -2 squared plus 20 times -2 plus 25 equals 5 times +4 plus -40 plus 25. So that's 20 minus 40 plus 25, which equals -20 plus 25, which equals +5. Which means our vertex is at -2, +5, and our vertex form is y equals the value of a times x plus 2 plus the y value of the vertex. All you had to do to solve number 1 was write it in vertex form. Let's say everything I'm saying to you right now feels crazy alien and impossible, and I'm going too fast and you don't get any of it and you don't understand. Okay, fine. As I recall, I showed you how to use your calculator to find the vertex. So let's do that. Turn the calculator on. Go to y equals and type in the equation that I gave you in number 5. And there's the graph. Use the calculation feature. Minimum. Left bound and right bound. There's my cursor. There's my left bound, there's my right bound, and then here's my guess. Kapla! The vertex is at -2, +5. Which means you can go right here and plug everything into your vertex form. Y equals a times x minus h, so that's going to be +2 squared, plus 5. Vertex -2, 5. And then to graph, all you've got to do is go check your table. The vertex, -2, 5. Another point, negative 310, negative 110, and you're done. For the graph, this is all I needed. Change color, put in the parabola, write the vertex, negative 2, 5, and I believe the other point we identified was negative 1, 10, got that straight from the table in the calculator. That was it. It could have been that sloppy. Sketch the graph. Locate 2 points, including the vertex. How do I know if it's right? Is your graph in the right quadrant? Is it over here? If your graph was over here, I would have known it was wrong. If it was down here, I would have known it was wrong. If it was down here, I would have known it was wrong. Sketching that graph right there, identifying the vertex, tells me you were right. You knew where it was, and then this point comes straight from the table. It wasn't hard. Maybe you didn't feel like you didn't have enough time, I don't know. It wasn't anything you couldn't have done. You have your calculator, which you can use to find the vertex. You have x equals the opposite of b over 2a, and then plug x into the equation to find the vertex. You have completing the square to find the vertex. And then to sketch the graph, again, use your calculator and the table feature. Not anything you can't do. The problem on the back, I think, was even easier than the problem on the front. Not that either one was particularly difficult. To write this equation in standard form is just to do order of operations. X plus 2 times x plus 2 plus 5, x squared plus 2x plus 2x plus 4 plus 5. That's just the FOIL strategy. Distribute that negative, combine the two x's in the middle. Negative x squared minus 4x minus 4 plus 5. Negative x squared minus 4x plus 1. I'm sure you noticed me skipping over this step and this step frequently in class because it really isn't necessary. 2 plus 2 is 4. 2x plus 2x is 4. Every time I FOIL two binomials, I know I'm going to add the middle terms. So why not go straight to negative 4x? And once I've distributed my value of a, I know these last two terms are going to combine together. So why not go straight to positive 1? Negative 4 plus 5 shouldn't be the sort of thing that slows us down. Now to sketch the graph, label both the vertex and another point, you can use a calculator or just look at the equation. The original is given to you in vertex form, which means the vertex is negative 2, 5. If you don't like or trust that, okay, fine. X is the opposite of b over 2a, so then x must be equal to the opposite of negative 4 divided by 2 times the opposite of 1. Multiply all that out, keep all your negatives straight, and you wind up with x equals negative 2. Plug negative 2 into the standard form equation. The opposite of negative 2 squared minus 4 times negative 2 plus 1. Negative 2 squared is positive 4 times negative is negative 4. Negative 4 times negative 8 is positive 8 plus 1, giving us positive 5. And the vertex that we expected. Or again, you could use a strategy on the calculator where you plot the quadratic in y equals, use the second trace or the calculation menu to find the minimum or the maximum, and then use the table feature to find an additional point. Here's our calculator. Turn it on, y equals, clear out the first quadratic and type in the second. Negative x squared minus 4x plus 1, and have a look at the graph. Now you can sketch the graph really easily. And you can find the vertex if you're not comfortable with the equations. This time it's a maximum, so find your left bound, enter, right bound, enter, make your guess, which looks suspiciously flat here, but it's not perfect. Far from it, it's a computer. But clearly the vertex, negative 2, 5. So you sketch this into that grid that I gave you, you label that point, and then you go over here to your table, and you go, aha! When x is negative 1, y is 4. Or when x is 0, y is 1. And you plot that point. Next time we do something like that, I'll be sure to limit the discussion so you have more time to get this quiz done. Because I suspect that was the main reason why we didn't get all the way to completion. This graph right here, while pretty sloppy and imperfect, would have sufficed. -2, 5, and what did we say? Was it 0, 1? And as you recall, from y-intercept form, from standard form, you already had an additional point without even going to the calculator. The y-intercept is right there. When x is 0, 0 squared minus 4 times 0 only leaves +1. So when x is 0, y is 1. Which means that once you converted from vertex to standard form, just by doing the order of operations, you had 2 points, the vertex and the y-intercept, which was enough to complete the problem.